This video is the start of Unit 5. It is going to cover lessons 5.1 and 5.2, and this unit is all on sequences and series. So the good news is most of this should be review, especially the first couple of lessons. So if you recall back from Algebra 1, you learned what a sequence was. It is formally defined as a function that has as its domain, so remember domain are your x's or your inputs, it can only be the set of positive integers. Now that's important, it can only be an integer. There will be no decimals. So you can't have an input of like 3.5. Okay, so there might be a question where they ask you to explain why you can never get a certain output. And you may have to figure out whose input that would be. And if it comes out to be a decimal, like 7.5, it's usually 0.5. If it comes out to be 7.5, then you say this output won't exist with this particular function because the input is not an integer. So it has to be an integer. Your inputs have to be positive integers. So they start with 1. 1 is the first positive integer, and then it goes on forever towards some number n. Okay, so we're going to start off by doing a review. This should be a review exercise. It says a sequence is defined by the following equation. A of n equals 2 times n minus 1. So it says find the first 3 terms of the sequence, and the terms are denoted by these subscripts. So a sub 1, a sub 2, a sub 3, those are what terms you're finding. So the first term is a sub 1. So to find a sub 1, you're plugging in 1 because that's the first positive integer in for n. So a of 1 would be 2 times 1 minus 1. 2 minus 1 is 1. The second term, a sub 2, you would get by plugging in 2 for n. So it'd be 2 times 2 minus 1, which is 3. And then the last one we have to find, the third term, you would find by plugging in 3 for n. So that's 2 times 3, which is 6 minus 1 is 5. Which term has a value of 53? So we know our result. We want to get 53. And I don't know which n, which term I'm going to plug in to find 53. So I don't know that. So I'm going to leave it as n. And now you're just going to solve for n. So add the 1 over to the other side. And then divide the 2 over, you get 27. Well, since n is also the same as the term, notice over here when we inputted 1 for n, that was our first term. When we inputted 2, that was our second term. So that means it would be the 27th term. So if you plugged in the 27th number, it would give you 53. Now, sequences can also be described by using recursive definitions. What that means, if it's recursive, it means to get the next input, you have to use the previous input. So if you want to put in parentheses, to get the next, sorry, I think I said input. It should be output. To get the next output, you have to use the previous output. So whatever, it's kind of like when we did compositions, how you had to find the output when you inputted a certain number into the first function, and then you took that output and inputted it into the second function. It's kind of the same thing, except for you could keep going. It's not just going to be 2 or 3 functions. So given the following, it's a recursive formula. So you'll notice this notation right here always. It's saying to find f of some number n, you have to take whatever f of n minus 1 is. Well, if you subtract 1, you're doing the previous input. So, like for example, to find f of 3, you would need whatever f of 2 was, because 3 minus 1 is 2. So whatever f of 2 was, I don't know, let's say it was 100, then you would add on 5. So it'd be 105 would be f of 3. So it all depends on, they have to give you a starting output and input because you're going to need that to get the next one. So they have to kind of give you the first answer. They have to give you the first one. and then you're going to use that to find the following inputs. So you could use whatever f of 1 is to then find f of 2. Then you're going to use f of 2 to find f of 3, and then you're going to use f of 3 to find f of 4, and so on. So you need to know, they have to tell you one input and output, and then you're going to use those to find the next inputs and outputs. So generate the first 5 terms of this sequence. So they already gave us the first one. F of 1, the first term, was -2. So I already have the first one. So now to find f of 2, I'm going to do a lot of writing at first just to show you, and then I'm not going to write all of this out every single time. So this would be f of 2 minus 1 plus 5. Well, f of 2 minus 1 is known as f of 1 plus 5, and we know what f of 1 is. F of 1 is -2. So this becomes -2 plus 5, which is 3. So my final answer for f of 2 is 3. So notice I used f of 1's output and then just added 5. So now to find f of 3. To find f of 3, I'm going to need whatever f of 2 was and then plus 5. Well, f of 2 turned out to be, and I'll use a different color, f of 2 turned out to be 3. So I can replace f of 2 with the number 3 and then add 5, that's 8. F of 4 is going to require me to know what f of 3 was plus 5. Well, f of 3 was 8, so that's 8 plus 5, which is 13. And then lastly, I'm running out of room here, f of 5 is going to require me to do whatever f of 4 was, which was 13 plus 5, which is 18. So you will notice I went from -2 to 3 to 8 to 13 to 18. You should notice what's happening each time I get the output of the next input. I'm adding 5 every single time. So this says, now part B, this is important because this is what you really need to take away from this lesson, was determine the value of f of 20 without sitting here. I mean, you could sit here and find f of 6, f of 7, f of 8, all the way up to f of 20. But there's an easier way to do it. If you look back at what we did, to find f of 2, you will notice that we added on from our starting output of -2, we added on 1 5. To find f of 3, we took our starting number, which was -2, and we added on 2 5s. 2 5s would be 10. 10 minus 2 is 8. F of 4, we added on 3 5s. 3 5s is 15, plus our starting output of -2 gives me 13. So you're always adding on the number of whatever you're adding. So we're adding 5, and we're adding on 1 less than whatever term we're finding. So f of 20, we'd be adding on 5 19 times. It's always 1 less. So you would add on from -2 to find f of 20. You always start with your first output, and you would add on 5 19 times to find the 20th term. Because remember, if you go back, to find f of 2, we added 5 1 time. To find f of 3, we added 5 2 times. So it was always 1 less than the term we were finding. So that turns out to be 93. So you could sit there and do it, but honestly, on the Regents, they'll probably give you some ridiculously large number, like f of 720. You don't want to sit here and do that up to 720. All right, next one says, exercise 3, last one, determine a recursive definition. So you're going to come up with, if you look back up here, this f of n, you're going to come up with that. They're going to give you the outputs that you would get for the first term, second term, third term, fourth term, fifth term, sixth term, and you have to try to figure out what did you do to the previous. It's recursive, so you're using the previous output. What did you do to that previous output to get the next output? So they love the notation. First of all, you got to understand, you got to know your starting value. So the first term was 5. So f of 1 is 5. Then you got to use your f of n notation. They told you to. They could use a different variable. They told us to use n. So you got to take the previous output, which was 5, and what did you do to it to get the next output? Well, from 5 to 10, you got to ask yourself, okay, well, I added 5, I multiplied by 2, but you got to do the same thing to go from 1 to the next. So did I add 5 then to go from 10 to 20? No. Did I added 10. Well, that's not what I did in the first two, but I did multiply by 2. So far I'm noticing that if I multiply the first 2 by 2, I get the next one. Let's just make sure that continues. 20 times 2 is 40. 40 times 2 is 80. 80 times 2 is 160. So my recursive formula would be that I'm taking the previous input's output and I'm multiplying it by 2. And there's your answer. So just remember, recursive means you're going to be always having this n minus 1 in your formula somewhere because you're using the previous output to get your next output. Okay, so moving on to lesson 5.2. 5.2 also should be a review. It is on arithmetic and geometric sequences. You need to recall that arithmetic really just means you are adding to go from one output to the next. Now, you could be adding a negative number, so it's going to look like subtraction, but you're really adding, okay? So even if you're subtracting, I'll put in parentheses subtracting, but you're not really subtracting, you're adding a negative. So you're always adding. Geometric, you are multiplying to go from one output to the next. Now again, it might look like you're dividing, but you're really multiplying by a fraction. For example, if you were dividing by 2, that's really multiplying by 1/2. So if you are telling yourself, okay, wait, I'm dividing though to go from one number to the next, well, you're really multiplying by a fraction, so it is geometric. So geometric, you should be thinking, are you multiplying to go from one to the next? Arithmetic, are you adding or technically subtracting to go from one to the next? D, by the way, if you look in the notation up here, you'll see D and you'll see R. So D is the number that, it's the common difference, D for difference, it's the number you're adding or subtracting to get from one output to the next. R is the common ratio, it's the number you're multiplying or dividing by to go from one number to the next. So just a quick review, this is from last lesson. They gave us this recursive, notice the n minus 1, it's using the previous output, so it's recursive, and it's arithmetic. The huge key, I know they said the word arithmetic, but you'll notice the +6, you're adding. This one right next to it is geometric, you're multiplying by 1/3. So you need to be able to tell if it's arithmetic or geometric without being told that it's arithmetic or geometric. So if you're adding or subtracting, it's arithmetic, multiplying or dividing, geometric. Okay, so we need to do the next 3. So they gave us the first one. So we have to find f of 2, which is going to require f of 1 plus 6. Well, that's 2 plus 6, which is 8. F of 3 is going to require f of 2. F of 2 was 8. Plus 6, which is 14. And then f of 4 is going to require whatever f of 3 was, which was 14, plus 6, which is 20. You should notice each time we added on 6 to go to the next term. Geometric, you're multiplying by 1/3. When you're multiplying by a fraction, remember you're really multiplying by the top, dividing by the bottom. So they gave us f of 1 is 9. So to find f of 2, you're going to need whatever f of 1 was, which was 9, times 1/3, which is really just 9 divided by 3, which is 3. F of 3 needs f of 2, which turned out to be 3 times 1/3, which is 1. And the last one, f of 4, needs f of 3, which was 1 times 1/3, which is 1/3. So you should notice you were dividing by 3 each time you went from one term to the next. Okay, so exercises 3 and 6, but these are like huge. This is the meat of this lesson. You're going to be asked to come up with your recursive formula, and you got to notice kind of some patterns, and that'll help you come up with it. So we are first doing in exercise 3. You should notice this is arithmetic because you're adding 3. So that should be a huge hint that it's arithmetic. And they told you that the first term, his output is 5. So they want you to figure out what a sub 2 would be. So a sub 2, you're going to need whatever a sub 1 was, and you're going to add 3. Well, a sub 1 was 5 plus 3 is 8. A sub 3 would be whatever a sub 2 was plus 3. Well, that was 8 plus 3, which is 11. And lastly, a sub 4 would be whatever a sub 3 was plus 3. Well, that's 11 plus 3 is 14. Now it asks you, this walks you through coming up with your equation. It says, how many times was 3 added to 5, which was our first output, in order to produce a sub 4? Well, 5 plus what is 14? 5 plus 9 is 14. So how many times was 3 added? It was added 3 times. So that was to get a sub 4. So again, it's always one less. Whatever term you're finding, you're adding whatever the d is. The d in this one was 3. So you're adding 3 times to get a sub 4. If you were doing a sub 5, you would add 3 4 times. So it's always one less. So this answer is 3 times. If you were finding a sub 100, you would add 3 99 times. So use your result to find a sub 50 quickly. So you always start with the first output of the first term. That was 5. And you're going to add on the number 3 49 times. It's always one less than the term you're finding. So that turns out to be 152. Now we can use our pattern of what we've noticed to come up with a formula to find any term. You could find the 1,000,000th term using this formula. So to find a sub n, any number n, you're always going to start with the first output. We start with 5 in this case. And you're going to add on one less than whatever term you're finding. So that's parentheses, n minus 1 times, and then your common difference, which in our case was 3, but it could be any number. So we'll call it d. So you start with the first output, add on one less than whatever term you're finding times whatever the common difference is. So again, if you're finding the 37th term, then you would do 36 times whatever the common difference is. In this case, it was 3. If it was plus 7, then you would do 7 for D. Okay, same thing for geometric except for your multiplying. So it's a little different. So they gave us the function a sub n is you take the previous term, n minus 1. So if it was a sub 4, you would find a sub 3, and you're going to multiply that by 3. So they have to give you a starting output. So the first term's output is 2. So we want to find a sub 4. Well, without knowing our formula, we'd have to sit here and find a sub 2 first, which would be a sub 1 times 3, which is 2 times 3, which is 6. Then we would find a sub 3, which would be whatever a sub 2 was times 3. Well, that was 6 times 3 is 18. And finally, to find the one they actually want, you would do a sub 3 times 3, which was 18 times 3, which is 54. So we had to sit here and do 2, 3 just to get to my answer for 4. Well, let's see if we can come up with a pattern, and then we can write a formula so we don't have to sit here and find the previous ones. We can just find the one we want. How many times did you need to multiply 2 by 3 in order to find a sub 4? So our answer for a sub 4 was 54. Our starting value, our starting output was 2. How many times did we multiply 3 by to get 54? Well, if you notice, 54 divided by 2 is 27, so 3 times 9, right? So that's 3 times. So it's 1 less than the number, whatever output you're finding. So determine the value of a sub 10. So to find a sub 10, you would do a sub 1, which is the first one, times, our multiplier was 3, and we're going to raise it to the one less than 10, so that would be the 9th power. Going back over here, 9 really quickly is 3 squared. So 3 times 3 squared is 3 to the 3rd. So let me rewrite that so you can see where that came from. So this would be 2 times 3 squared, right? 9 is known as 3 squared. Well, you know from last unit, you can combine these two 3's because they have the same base. That's a 1. So that's 2 times 3 to the 3rd. So this number here told me it was 3 times. This number here, I got 9 here because it's 1 less than 10. So if you plug in what a sub 1 was, it was, what was it again, 2 times 3 to the 9th power. It's a really large number. It's 39,366. So to come up with our formula, it's going to be to find any term, a sub n, you need the first term times whatever the multiplier is. In our case, it was 3. They told us that we were multiplying by 3. And you're going to raise that to the n minus 1 power. So 1 less than whatever term you're finding. Now here is the excellent news. You need to know these two formulas right here. Are you ready for it though? You are given these two formulas. Here is your Regents reference sheet. You will notice they are right here. You do not have to memorize them. You just have to know what the letters mean and how to use it. So therefore, you will not be required to memorize it for any test or quiz I give you. I will give you these formulas. You just need to know what N and D and R stand for. So just make sure you can use them properly. And that is it for lessons 5.1 and 5.2.